mathematicians, it's Justin again. Mia and I are still exploring the Mathematical Masterpieces exhibit at the Miaville Art Museum. Our next stop is a special gallery inside the exhibit that's all about the geometry skills we've learned so far in this unit. This part of the exhibit needs a few finishing touches though, and that's where we come in. We've been asked to help as junior curators by checking the displays and making sure everything is labeled and explained correctly. Once we've finished, the gallery will be ready for visitors so they can explore and learn just as much as we have. By the end of today's lesson, you'll be able to apply your understanding of lines, angles, and polygons to solve a variety of problems. Have your guided notes ready, and let's review our geometry skills as we polish up this gallery together. As junior curators, it's our job to double check the exhibits and make sure everything is identified correctly. This display is our first stop, and it's all about the building blocks of geometry: points, lines, line segments, and rays. Check out the plaque next to this display. What do you notice? Oh, it looks like some of these descriptions aren't labeled correctly. Think you could help? Closely observe the artwork. Check the names for the lines, line segments, and rays. Are they correct, or do they need to be fixed? Then check the line relationships. Do the parallel, perpendicular, and intersecting lines match what you see? Pause the video here to record your thinking in your guided notes. Line FD needs arrows added to the bar to indicate that it goes on forever in both directions. Line segment LB needs a bar with no arrows, and HE should be moved to the line segment category. Line CF and ray JG are both labeled correctly. Now for the line relationships. Ray JG and line FD and line segment EH and line segment LB belong in the perpendicular category, not parallel. Line CF and line segment LB are perpendicular, so the symbol should be changed. Line CF and line segment EH are parallel, but listed in the wrong section. And line CF and line FD should be added to the intersecting lines list. Nice job spotting the mix-ups and getting the plaque ready for display. Our next curator challenge is working with angles. There are 2 angles shown in this display. Our job is to measure each one using a protractor. Name the angle, record the angle's measurement in degrees, and label it as acute, right, obtuse, or straight. Then draw, name, and label a straight angle and an acute angle to complete the set. Pause the video here and record your thinking. Angle TWX is a right angle that measures 90 degrees. Angle PSR is an obtuse angle that measures 151 degrees. For the angles you drew, your straight angle should form a line and measure 180 degrees, and your acute angle should be less than 90 degrees. Each one should be named with 3 points, with the vertex in the middle. Moving on to the next display, this one's all about polygons, some regular and some irregular. But the plaque is missing key details. We need to help finish the display. For each polygon type, fill in either the name or the number of sides. Then explain the difference between a regular and an irregular polygon. Use examples from the display to support your explanation. Pause the video here to add your thinking to your guided notes. Make sure your chart correctly shows the names and number of sides for each polygon, like this. A regular polygon has all sides and angles equal, like the triangle or heptagon in this display, while an irregular polygon has sides or angles that are different, like this quadrilateral or hexagon. Hatch marks show equal side lengths, and angle arcs show equal angles. These symbols help us tell the difference. This display shows different types of triangles. What do you notice about their side lengths and angles? Give each triangle two names, one based on its side lengths and one based on its angle types. Then, find the triangles with missing angle measurements. Use what you know about the total angle measurement in a triangle to figure out the missing measurements. Pause the video here and show your thinking in your guided notes. There is one right isosceles triangle, an acute equilateral triangle, an obtuse scalene triangle, and a right scalene triangle. Since all triangles have a total angle measurement of 180 degrees, the missing angle for the first triangle is 45 degrees, and the other missing angle is 27 degrees. Great work classifying each triangle and finding the missing angle measurements. The final display features statements about quadrilaterals, and every one of them is correct. But the museum needs our help adding explanations that tell visitors why each statement is true. These statements are: a square is always a rhombus, but a rhombus is not always a square. All rectangles are parallelograms. And some quadrilaterals don't fit into any of the special categories like trapezoid, parallelogram, or rectangle. Explain why each statement is true using quadrilateral properties like parallel sides, right angles, or equal sides. Pause the video here and record your explanations for each statement. So, what makes each of these statements true? Well, the first statement is true because a square has 4 equal sides, just like a rhombus. But a square also has 4 right angles, and a rhombus doesn't have to. So every square is a rhombus, but not every rhombus is a square. All rectangles are parallelograms because rectangles have 2 sets of opposite sides that are parallel, which matches the definition of a parallelogram. And finally, a quadrilateral is any 4-sided shape. But not all of them have parallel sides or equal angles. If a 4-sided shape doesn't match the rules for trapezoids, parallelograms, or any other type, it's still a quadrilateral. It just doesn't have a more specific name. Awesome job, mathematicians! Thanks to your hard work as junior curators, the Geometry Gallery is ready for visitors. You helped label every point, line, angle, polygon, triangle, and quadrilateral with care. Now the entire Mathematical Masterpieces exhibit is even better, because it doesn't just show beautiful shapes, it teaches visitors about the math behind the art. So, what have we learned today, besides the fact that museum curators have to think carefully about every detail? Well, now you know how to describe and name points, lines, segments, rays, and line relationships. You've practiced measuring and classifying angles and finding missing angle measurements. You can name polygons by their sides, explain the difference between regular and irregular polygons, classify triangles by sides and angles, and calculate missing angles based on 180 degrees. And finally, you know how to describe quadrilaterals and use symbols to show their side and angle properties. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with lines, angles, and polygons. This is our angles, triangles, and quadrilaterals wrap-up lesson, which means the practice levels will review everything we've learned throughout the beginning of the unit. There's an activity to help you reflect on your progress and decide if there are any lessons you'd like to revisit before the mid-unit assessment. Remember, you can review any of the lessons at any time, because in math, as in life, every effort adds to your success. I'll see you next time.
Hey, hey.